Hi, my name is Laura Foley, and I am a recent member of the SSPC and University of Limerick alumni. So I was just asked to talk a little bit today and give kind of a brief presentation on some of the work that I carried out during my PhD over the past 4 years and kind of some of the opportunities I received with being a member of the SSPC. So my PhD thesis was entitled Method Development for Effectively Spray Drying Small and Large Molecules, and I did this through integrating formulation strategies and process optimization. So before I get into too much, I just wanted to give kind of a brief overview on kind of my scientific journey. So I spent the last 8 years in UL. So my journey started in 2017, where I started my undergraduate degree in industrial biochemistry. Kind of the course of my study, I got the opportunity then to carry out a cooperative placement with Beckman Coulter, and this was in O'Callaghan Mills in County Clare. So this was a 9-month placement, and I got to work with the R&D department here. And then in 2021, I completed my undergraduate degree with first class honours, and then in the same year, I started my PhD. So I started this with Professor Emma O'Reilly's research group at the Bernal Institute in Limerick. So with this, then I was a member of the SSPC. So we got the opportunity to present at various team meetings where we met other SSPC students and industry partners, where we discussed and presented our work. We also had some industry days where we got to go to various companies and integrate with the employees there and discuss some of our findings. And then I also got to present separately at some national and international conferences. I got to kind of carry out some outreach work where I got to talk to various primary and secondary school students about kind of my journey in STEM and kind of some of what I'm doing. And then I also got the opportunity to carry out a placement. So this was with an SSPC partner. So I got to carry out this placement in APC Limited. So they're situated in Cherrywood in Dublin. And here I kind of got to integrate into the pharmaceutical industry where I collaborated on various projects and kind of got to share some of my knowledge and some of the work that I've been doing over the past 4 years. So in 2025, I completed my PhD, so May of this year. And kind of the three key things that I looked at was drug product development, expertise in spray drying in terms of both small and large molecule, and then formulation and process optimization. So kind of looking at some of the skills and expertise I developed over the course of my studies. So I broke this down into three key sections: technical, scientific, transferable, and soft skills. So in terms of technical and scientific, so I look at drug product development and formulation. So I designed and optimized spray drying processes for small and large molecules. So these were kind of to look at increasing things like yield, stability, controlling particle size and morphology. I also looked at spray drying technology itself, so varying the loops that I use, different gases, different solvents, the combination of solvents, the addition of various excipients, and kind of the parameters then around that. And then looking at process development and optimization. So I applied design of experiments, so different DOEs, to develop kind of robust formulation strategies, which enabled me to identify kind of critical process parameters that influence my final powder product depending on what I wanted to achieve. And then lastly, I looked at various analytical techniques. So I characterized the products using different solid state techniques, and then they varied between small and large molecules. So I looked at different things like DSC, TGA, HPLC, FTIR, PXRD. And then in terms of the large molecule, I looked at things like circular dichroism, UV-Vis. I did different kinetic studies, various assay testing, fluorescence spectroscopy. So yeah, a wide range of analytical techniques. In terms of some of the transferable skills, so these include things like critical thinking, regulatory and GMP awareness. So I kind of developed those skills mainly in both my placements. So in the undergraduate cooperative placement where we used GMP, and then also I collaborated on projects in APC where they did have GMP implemented. And then also project management and prioritization, along with data-driven problem solving. So then in terms of some of the soft skills, so communication. So as I mentioned, I got the opportunity to present at various conferences. So this was kind of strengthened my oral communication, especially then presenting to different audiences. And then written. So I have various publications um, out at the minute and some under review. And then some other skills include adaptability, initiative, problem solving. So this was kind of prominent in my day to day. And then lastly, attention to detail. So this slide then is a bit more specific to the work that I did. So as I mentioned, my thesis was entitled Method Development to effectively spray dry small and large molecules. And this is kind of an overview on how I did that. So I represented this as a roadmap. And as I mentioned, I look at small and large molecules. And as we can see, as we move through the road from the bottom to the top, we increase the size and the complexity of the molecule. So firstly, I looked at aquafenicin, which is a small molecule expectorant drug. So it's around 200 grams per mole. And we looked at kind of alternative delivery approaches. Um, can we have like a targeted approach? Can we engineer the particles and ensure their stability over time? Then moving from this, we looked at our first kind of large molecule, which was lysozyme. So this is around 15 kilodaltons. And again, we looked at process optimization, integration of different excipients, the stability over time. We looked at different kinetic testing and an assay just to ensure the structure and everything of the molecule was intact. And this is also kind of a time sensitive study as well. So we had to factor in all those. And then building on this knowledge then and the knowledge that I obtained in chapter one, we looked at spray drying human fibrinogens. This is quite a large molecule, it's quite complex. It's 340 kilodaltons, and it's currently freeze dried. So we kind of looked at some of the challenges in moving from freeze drying to spray drying. And then we also wanted to see could we reduce the amount of excipients that were needed and ensure that our product was stable over time. So that's kind of the main things that I looked at in my work. So just to kind of summarize that, I used spray drying to address kind of the key challenges faced by the pharmaceutical industry with an overall goal to improve accessibility and ease of use. So we use spray drying strategies to guide formulation of various molecules of different sizes and to achieve various critical quality attributes. So these would be things like particle size, particle morphology, the crystallinity, its stability over time. Spray drying itself offers a broad utility in terms of particle control, continuous processing, and reformulation. We explored alternative delivery routes. So, as I mentioned, spray drying is important for process control. So, we were able to kind of tailor our particles for targeted approaches and pulmonary delivery applications. And then lastly, we examined moving from freeze drying to spray drying of fibrinogen. So that's kind of a brief overview of the work that I carried out over the last 4 years. I was very, very lucky to be a member of the SSPC community and all the networking and the connections that I made, all the conferences I was able to attend. It really, really added value to my work. So I'd just like to thank you for listening today. I left my contact details on the slide here, and if you have any questions, feel free to reach out. But thank you for your time and thank you for listening.